I'm Darshika Senadira from Apari, joining you from Sri Lanka. So it's truly a pleasure to host this gathering of experts and leaders from the globe. And your presence here reflects the commitment to advancing sustainable pest management solutions for our region and beyond. So to begin, I will give you a very quick recap to our last session. And Dr. Stella from Crop Life Africa Middle East opened the discussion during the last session, and she shared valuable insights regarding the market potential and existing gaps for biopesticide in Africa and Middle East. She also highlighted key regulatory challenges affecting the growth of the sector in the region. But the most importantly, she introduced a call for holistic systems through the proposal of the Biological Crop Protection Products Access Index or BioCOPA Index. This is a tool designed to track sector progress, identify areas for improvements, and support better aligned policy, regulatory, and market action. So, Dr. Stella has invited all of you to participate in co-designing this index, and I will be sharing her contact details and resources in chat box shortly. So that's the recap to the last session, and once again, a warm welcome to each of you. Now, I would like to invite Dr. Ravi to open the discussion and moderate the session today. Over to you, Dr. Ravi, please. So you are on mute.
Yeah, thank you. Yeah, greetings to everyone, and thanks for joining. We see today participants not much in number right now, but of course from Europe, from Africa, and from Asia, which is a good sign. It's a large number of participants from diverse region, which is important. And Darshika has given a good brief background on what is this community of practice and how we interact and what happened last time and all. I'm not going to say much on the community of practice or on the biopesticide because generally we end up with quick question answer session at the end. We like to have some good time at the end for question and answers. I would like to introduce we have two speakers this time, one from Russia and one from Sri Lanka. And first of all, I would like to introduce our speaker from Russia. He is a young man, Mr. Igor Vilkov. He is an international affairs manager in All Russian Plant Quarantine Center, which is subordinated to Ministry of Agriculture of the Russian Federation. And he has a lot of responsibility as international affairs manager, which includes cooperation with FAO, cooperation with IPPC, cooperation with European and Mediterranean Plant Protection Organization, and also cooperation with leading research centers in the field of plant quarantine, as Plant Health Laboratory at Julius Kuhn Institute, Germany, and Plant Health Laboratory at in France, and also in the Regional Agency for Agricultural Development of Fruit Venezia with Italy. So he is working globally. He is into the management of participation of experts, regular review. It's an overarching responsibility he has. He also takes care of the organization of joint laboratory studies and participation and organization of international events and so on. If you look at his background, his academic background actually is he's a Bachelor of Science and Master of Science in Soil Science and more into the soil ecology and agrochemistry. And he has been with the Southern Federal University, the Institute of Philology, Journalism, and Intercultural Communication, additional higher education program, and he has been a translator of the German language. And then he has been also there as a postgraduate course on soil science, which he did from Southern Federal University. He has a mix of qualification, like from science to soil science to communication to international affairs management, and he had shown keen interest in the biopesticide area, and he's going to speak to us on what uh, the Russia is doing, in fact, in this field. And we had been in touch since few months, and we also made a presentation in the Russian Academy of Science before to see how we can interact more and all. It's a growing relationship between Russia and Apari. And I would like to now invite uh, Mr. Igor Vilkov to please make his presentation on biological crop protection, some key facts on the current situation in Russia. Mr. Igor, the floor is yours.
So many thanks, Mr. Ravi, for your profound and comprehensive presentation of myself. It's a great pleasure to receive an invitation to be a speaker here today. So in order to save your time, I will start with presentations. So I will share my screen. Okay, so let's start. In order to start, we need to know what is NIKR. So the Federal State Budgetary Institution, All Russian Plant Quarantine Center, plays the unique role in the system of Roslekosnadzor institutions. It is the central Russian plant quarantine laboratory managing a robust network of regional branches and laboratories, and a scientific center of international importance. Now, let's speak about our ambitious goals and our ambitious tasks, which were set by our Mr. President. So the task is to increase by 25% the production volume of the Russian agro-industrial complex. And if we compare the amount of the production to 2021, it will be 1.5 times more. The increase in the quantity and quality of yields can be achieved through more intensive use of organic and mineral fertilizers, preservation of the crops from pests and diseases through the use of pesticides, widespread introduction of biological methods of plant protection. And this is the key of how we can achieve this goal. And if we speak about global market of biopesticides, it will grow at about 16% from 2022 to 2029. The leading markets for biopesticides in the world are North America and Europe. Many governments in North America and the EU have introduced strict regulations to limit the use of chemical pesticides to prevent environmental damage. So we are now living in a great time to use the opportunity to improve and to enhance the use of biological protection means. And that's why we are developing this direction rapidly and profoundly. But still, the market of biopesticides in Russia is less than 0.5% of the world market. If we see the situation in the European Union, they have already registered about 1,500 active ingredients of pesticides and which are regulated. So about 1,000 of them are not approved for use. And based on the results of post-registration control, outdated pesticides active substances are re-evaluated and banned and replaced with substances that are safer for humans, animals, and environment. And as of 1st of December 2024, the Russian Federation uses 25 active ingredients, which are not approved in the European Union, and included in more than 880 preparations, which compares and which makes 44% of all pesticides used in Russia. Also, over the last 20 years, the number of trade names of pesticides registered by the Ministry of Agriculture of Russia has increased fourfold. The volume of pesticides application over the 5 years has increased by 50%, from 150 to 230,000 tons. The application of mineral fertilizers has exceeded 5.5 million tons on average 70 kilograms per hectare, an increase of 20 kilograms per hectare over 5 years. And we see here some possible risks: that decrease in safety of grown products and non-compliance of Russian products with the requirement of important countries, so reduction of biodiversity, and could also lead to some environmental damages. And also taking into account the export orientation of our agro-industrial complex, it is necessary to accelerate the ecological transition, abandon obsolete active substances of pesticides, and accelerate the biologization of agriculture as far as possible. For instance, as of now, we have registered about 98 biopesticides, including Bacillus thuringiensis and Trichoderma sphaerorum, and so against Lepidoptera and soil pathogen suppressor, respectively. But still, there is a place to improvement, and that's why we are looking for new collaboration opportunities. So we are open to every institution involved in biological crop protection. And also, we are very welcome for everybody to attend our events. So in 2 weeks, we will have a big event in Baikal, so in city of Irkutsk, which will be devoted to the forest protection. And also we have a specific thematic section there, biological protection of forests. So everybody are very welcome to participate. So many thanks for your attention, and many thanks for taking me the floor. So many thanks, Mr. Chair.
Thank you, Mr. Igor, for giving a snapshot of a quick overview of where Russia is today in terms of biopesticide, in terms of pesticide, and how it is in the ecological transition, and what are the national expectations and national goals on that. Thank you so much for really giving a very crisp and succinct presentation, which of course will provoke many questions from many of the participants. But if you agree, we can take our kind of questions after both the presentations are made. And
Okay.
Okay, thanks. And we'll request the participants to put their comment or any questions in the chat box in the meantime. Thanks, Igor. It was really very quick and very nicely succinctly done. Friends, now I have a pleasure to invite Dr. Professor A.D.N.T. Kumara. He is a professor in entomology from Department of Biosystems Technology from Southeastern University of Sri Lanka. Professor Kumara is an accomplished entomologist and academician with over 2 decades of experience in agriculture research and higher education. So he brings a blend of both education and research. And currently, his research expertise lies in chemical ecology-based pest management. This is what we call EPM. All of us know IPM, but ecological or ecology-based pest management is a science which is coming up, which is having a strong focus on semiochemicals, biopesticide, and integrated pest management strategy, which is just a part of the EPM strategy. Professor Kumara has led and contributed to several national funded research projects, including development of semiochemical and nanoparticle-based biopesticide control technologies for key agriculture crops, such as coconut, rice, and maize, all of which are very important for Asia and the Pacific. He is a PhD from the University of Agriculture Sciences, Bangalore in India, and has published extensively in indexed and peer-reviewed international and national journals. He is the inventor of a PCT published repellent, gel for red palm weevil, You all may be knowing the importance of red palm beetle in the region, and he has filed 2 national patents related to pest management innovations. He has been recognized with multiple awards for excellence in agriculture research, including from SLCARP, that's the Sri Lankan Council of Agricultural Research Policy, which in fact is a member of APARI, and presidential awards for higher impact publication and Vice Chancellor's Award for Innovation in the past years. Now, Professor Kumara is a committed mentor and educator supervising PhD and MPhil students and contributing actively to curriculum development and quality assurance in biosystems technology education in Sri Lanka. So with these few words, I will now request Professor Kumara to please make his presentation on achievements and prospects of biopesticide for sustainable agriculture, uh, global trends and insights from Sri Lanka. Professor Kumara, over to you.
Okay, good afternoon from Sri Lanka. Thank you very much, Dr. Ravi, for your nice and informative introduction about me. Thank you very much. I will share my presentation.
Yes, Professor Kumara, it's over to you.
Yes, let me give 1 minute. I will
Sure.
share that my presentations. Sorry for inconvenience.
Okay, let's deep into the
Is it okay?
Yeah, it's very clear. Please go ahead.
Okay, thank you very much. Good afternoon from Sri Lanka. It's a pleasure to here today to discuss the advancement and prospect of biopesticide for sustainable agriculture, the global trends and insight from Sri Lanka. This topic is timely and critical as we seek eco-friendly solution in agriculture pest management while maintaining productivity and sustainability. Okay, let's begin our journey through this topic. To begin with, I'd like to give you a quick overview of what we will cover today. Our objectives include understanding of biopesticide, comparing biopesticide with synthetic pesticide, what widely we are using, as well as reviewing global and Sri Lankan developments, exploring classifications and mode of actions, and looking into commercialization challenges and discussing their future prospects. Today, you all know the modern agriculture faces major challenges such as climate change, pesticide resistance, and concern over food and environmental safety. This is where biopesticide come into the play or come into the field now. They offer pest control solution derived from nature, ensuring minimum harm to the ecosystems and the human health. So we'll see what are the biopesticides. I know you all know those are those are biopesticide, also a kind of pesticide. That's our origin from the natural or the biological sources derived from plants, bacteria, fungi, and some minerals used to manage pests and diseases while minimizing the environmental impact and promoting sustainable farming practices in the agriculture. If we go for the classification of biopesticide, in generally, we can classify microbial biopesticide, botanical biopesticides, biochemical biopesticide. In addition, next generation biopesticide, including RNA interference, RNAi-based, and genetically engineered biopesticides. These are these three classifications. Let's look the type of biopesticide. First, microbial biopesticide. Those are originated from the microorganisms. Especially in the Bacillus thuringiensis, it is widely used more than decades to produce insecticidal crystal proteins that specifically target insect pests. In the fungal biopesticide, those are also widely using entomopathogenic fungus like Beauveria brasiliana and Metarrhizium anisophyllum. In addition, some other fungus also we are using and exploring as a biopesticide. The viral and protozoan biopesticide, everyone knows the baculoviruses are used to control lepidopteran pests as well as some coleopterans. While protozoan biopesticides show potential by including diseases in target insect population. These pesticide classifications come into botanical biopesticides. Those are also available in the world and the market, especially in the neem-based formulations, pyrethrin, and some other plant extracts. Third category is biochemical pesticides. They are plant-derived compounds such as azadirachtin from neem or disrupt insect growth, plant volatiles and plant essential oils, and the insect-derived pheromones and allelochemicals. Those we can broadly categorize as the pheromones, allelochemicals, and allelochemicals mainly plant volatiles we can categorize as the pheromones. Those are very promising areas for the biopesticide, but some are available in the market as well. If we go for the mode of actions, a lot of publications are related to the mode of actions of the microbial biopesticides. You can see several mode of actions are activating, and those are toxic and control the pest organisms or the disease. And also these two slides indicating that how the uptake of the microbial pesticide through ingestions or penetrations of the insect cuticles. Afterward, it will convert and produce the active toxins, and toxins are acting as control agents for the pest. Then if we go, the biopesticide working fascinating way, they may disrupt pest feeding, reproduction, and egg hatching, those having the ovicidal effects, and also even nervous systems they affect, and they acting as some way of similar as synthetic pesticide as well. And some certain essential oils like semiochemicals alter the pest orientations and feeding preferences, reducing the crop damage without necessitating direct contact with the pest. Sex pheromones widely used as mating disruptions, mainly in the agriculture field, in addition to that for the pest monitoring. Botanical biopesticide having antioxidant, growth regulatory actions, and herbicidal effects. Those are some of the mode of actions. And if we consider the biopesticide, they have fascinating and various mode of actions. These are some comparisons between that synthetic pesticide towards the biopesticide. Biopesticides with synthetic chemicals, the benefits are clear because biopesticides are safer, more specific and eco-friendly. However, challenges like slower actions and reduced shelf life is there. But they are being addressed through the formulations, improvements, and nanotechnology can solve those challenges. If we concern the global contributions of biopesticide, as the previous our colleague mentions, how the world demand is going for the biopesticide directions. Globally, the biopesticide market is blooming, expected to triple from 2024 to 2032. In 2024, it is a US United Nations United States dollars 8.73 billion, but in predicted USD 28 billion in 2032. As he mentioned, in regions like North America and Asia Pacific, where organic farming and regulatory supports are expanding rapidly, and also major agriculture companies are investing heavily in the research and innovation, exploring the biopesticide compounds in the world. Recent global advancement, recent technological breakthrough have revolutionized biopesticide developments. Nanotechnology enhances the shelf life because nano encapsulations, and it also makes some targeted release of bioactive compounds, making that some problems we can solve with using that. Genetic engineering produce stronger microbes or the virulence organisms against the pest. RNA interference silence pest genes, offering precise control, while AI support optimized applications to precision agriculture. At that time, AI, we can get support for the development of the biopesticide applications, because we can use sensors, whatever essential time, we can directly spray or apply the biopesticide. Those are some global advancement. The biopesticides are more than just alternative for the synthetic pesticide. You all know they are enable of sustainable agriculture. The biopesticide can help to the improvement of the soil health, and also reduce the chemical residues in food and preserve the pollinators and enable biodiversity. They align with the ecological principles and sustainable development goals. This act through the pathogenic effects, antioxidant properties, and behavioral actions that behavioral modulations help suppress the pest efficiency and the sustainability. Then the technological advancement and application of that microbial formulation, nanotechnology, I already explained that role in integrated pest management, biopesticides, complementing sustainable agriculture as a biological control, with protect rotations, habitat manipulations, and also help reduce chemical pesticide dependency in the pest management. If we considering that biopesticide used in some available sustainable farming models in the world. For example, integrated pest management models in rice IPM in Asia, especially India and Philippines, reducing synthetic pesticide use and increasing the yield. And organic farming systems, organic vegetables and fruit farming in the European Union and Sri Lanka under certification and standards. They are promoting the sustainable biopesticide use. And also it used for the agroecological farming. Agroecology farms in Cuba and part of Latin America using trichoderma, compost tears, and local herbal formulations as a biopesticide. Then the community-based eco-farmings in Sri Lanka, Govimitura, it's some kind of a biopesticide and environmental farming systems. And India, zero budget natural farming is promoting zero pesticide usage. Then what are the challenges in commercialization and development of the biopesticide? There are several challenges with existing biopesticide, limited shelf life and formulation stability. Biopesticides, especially for the microbial and biochemicals, are sensitive to heat, UV light, and moisture. Then required special storage and handling, increasing logistical challenges and the cost. The second one is extensive and lengthy research and development and regulatory approvals, and the high production and application cost. In viability during transportation and application, especially those are posing for the microbial biopesticides, and inconsistency in the field performance. Once we are developing, the lab efficacy is very high promising. But sometimes if we go to the field applications, that may be resulting inconsistent performance with using our developments. And also the challenges with new technologies. Some countries like Sri Lanka, we are have the challenges. Those technologies are not much available in country like Sri Lanka. Therefore, we are not able to invest much and also engaging much research on those kind of fields. Then the current use of biopesticide in Sri Lanka, status, challenges, and opportunities. Current use, we have the growing interest in biopesticide, especially in organic farming. And also in 2021, the Sri Lankan government banned temporarily the use of the synthetic pesticide as well as the fertilizer. Even though the project is unsuccessful, the trend for the bio or the organic farming is increasing. In Sri Lanka, products including Bacillus thuringiensis and neem-based formulations are using, but most of the products are imported from some other countries. And also key institutions like Department of Agriculture, CIC Holdings, CRI, and like all universities are lead for the research and development of that biopesticide and the organic farming practices. If we concern the challenges in the biopesticide, limited availability, even though if we produce the market availability, startup like gaps are there. And also lower farmer awareness and inconsistent results. The product quality hindered widespread adoption, and also limited investment of both public and private sector for the biopesticide research we can identify in Sri Lankan situation. Even though we have the opportunities for the biopesticide in Sri Lanka, you know, we have a high diversity of the we have very high biodiversity. Give us access to valuable botanicals, as well as we have some labeled high value biopesticide ingredient like neem, cinnamon, cinnamon, it having a lot of qualities, and citronella, and some more herbal plants still not explored, also available. Then, if we concern the world green product markets, there is a high demand in global green markets. Scope for value-added processing and branding of Sri Lankan botanicals. Eco-labeling and organic market growth is increasing, and therefore we have the opportunity to rise in global demand and for the residue-free organic product, boost adoptions of the agriculture products like country like Sri Lanka and some other agriculture countries. Sri Lankan contributions of the biopesticide. What are the recommendations and way forward? The government policy shift. Sri Lanka has promoted organic and eco-friendly farming practices, notably during the 2021 ban on chemical fertilizers and pesticides, which increased attention from the biopesticide alternatives. Even though everyone know the 100% organic or banning chemical and synthetic pesticide is not practicable within 1 or 2 days, and within short period, there should be a stepwise converting process. Research and development institutes like Department of Agriculture and universities and research institutes are now conducting research on indigenous microbial bioagents and plant-based extract for the pest control. I already mentioned that registration procedure of biopesticide we have developed by the Register of Pesticide, and they given the guidelines how to register the biopesticide. These are the steps: product identification, regulatory framework, can check, prepare the dossier, submit the application, regulatory review, and after that approval. But it will take some lengthy time to come out the product to the market. These are some registered pesticide details in biopesticide in Sri Lanka. It is very few with compared to some other countries. Even though those products are imported and registered for marketing in the country, it is very low amount of our own products. These are some our developed products: red palmywill repellent gel and nano-emulsion biopesticide formulations. These are not much available in the market. This red palmy will only be commercialized to the selected provinces. Nano-emulsion biopesticides for the control of the fall armyworm, as well as for the other rice pest. The evaluation of the rice pest is undergoing, and it is still not in the market. Those are some our research outcomes. From that, I would like to conclude my presentation. Biopesticide offer enormous promise, from nanotech and RNAi to sustainable farming systems. They are at the frontier of green innovations, as well as realizing their potential requirement, not just science, but policy reform, investment, and grassroots awareness, especially for farmer awareness needed for that. The balanced science-driven approach combining both biopesticide and integrated pest management approach with modern precision agriculture will ensure the sustainability of both environmental and human health. From that, I will stop my presentation. These are my references, what I use for prepare this presentation. Thank you very much. I welcome your questions and look forward to your insight from all.
Thank you, Professor Kumara. I think your presentation gave a good background on some basics and on where we are in Sri Lanka and how you look at moving forward in Sri Lanka in the field of biopesticide. Well, friends, now both the presentations are open for discussion. I will, first of all, before making it open to public, there are already some curiosities shown in the chat. I will immediately ask Dr. Ghosh, Swapan Kumar Ghosh, to interact with Mr. Igor from Russia on his comment. Dr. Ghosh. Okay, maybe he's not there right now.
Yes, sir.
Yeah,
Sir,
you had some comments for the Russian presentation by Igor.
yeah, I would like to understand that how Russia is encouraging the exotic, the outside the country's biopesticide in their country, or or only they are promoting to the only the native formulation.
Yeah, so, Mr. Ghosh, as I mentioned, we are encouraging the use of different biologicals. They could be inland developed or some exotic. First, we evaluate their efficiency. We evaluate the possible risks of introduction. For instance, any possible associated risks. And if everything is fine, the biological application is promoted by the governmental strategy, so there is no further borders and hurdles if your formulation is considered acceptable and useful for the agriculture. But first you need to find your counterpart here in Russia and establish a joint venture, and so you can establish a good production here. Hope
Thank
that
you.
helps.
Thank you. We'd like to understand that you see, we have the technologies and all, and generally some countries are not allowing the outside microbes in their country. So if Russia's the guideline is like that, they are allowing only for the indigenous. Do you think that there is any potential to share the know-how of the technology there and bring the technologies for promoting in Russia from India?
Especially from India, there will be no, frankly speaking, there will be no borders. But still, the first step is if you want something officially established, it should be first solved on the governmental level. It's the first key and the first step. So there is no possibility for farmer just simply take strains into his luggage and move from the airport to the field and make some trials. No, there is no way he will be stopped. But if stakeholders, big stakeholders like research institutes in India, find a counterpart in Russia and establish a joint venture, and then it's possible also to exchange strains for the purpose of scientific needs. It's also permitted. It's also allowable here. And then it could be scaled up to the big production story and to big production facility and to develop. So that's how some commercial stakeholders like Syngenta do here in Russia. They establish joint ventures. They establish here production sites, and also know that Syngenta bought some biological factories here in Russia and in other countries, and they're acting like a consortium here, and they are exchanging their strains and they're making their first products, so under some commercial names. But also, if we speak about biologicals, it also could be tricky because every scientific and research institute could produce it itself, and they can go through their registration process. It's also a thing. And even some farmers can produce their own so-called biologicals. It's also of great interest for farmers because it's really reduced their costs of production, but they also need to see their results, some visible results. And that's why it's also, so I asked I have replied to Miss Rahman comment. So what stops their wide application of biologicals that the farmers need to wait? For instance, the chemicals, and if we apply them, they act quickly, and they act fastly. But for some strains, they need to develop in soil, they need to establish colonies, and they need to form colony with, and for instance, with some crops, especially it's the topic for some beans crops like soya, yeah, or soybean. We are acting, and we are developing this research is very actively. Especially, we have a specific research institute. It's so-called the Research Institute for Soybeans. It is located in the Far East because of geographical positions, as the soybean is one of the greatest crops. If we speaking with about the market with China, and so we need to establish, and we need to find some opportunities in China, especially for soy. It's of great demand, and that's why the production, and also if we speak about the cost of production, we need, and also for environment, and for the sake of environmental.
Yeah. Okay.
Thank you.
Thanks.
For sure, biologicals
Thank-
are great.
Thanks, Dr. Ghosh, for your question. And Mr. Igor, you have a comment or question from Francois. Francois is from GFAIR, working from Italy.
Yeah.
Yeah.
Yeah, I saw his comment. He asked how our center promotes use of trichoderma by farmers. So the use, so my written reply was very quick, but I will go into the details. So we have a communication strategy established here in NICAR, and it is in line with our communication strategy. We promote general knowledge for farmers and promote their deeper understanding of all of processes which are connected with the crop protection and plant quarantine and plant health. And one of the pillars of our communication strategy is to produce some media content. So we have our specific platform now it's located in RootU and VK, so in our social networks. And we promote the use of biologicals by raising the awareness by means of social networks.
Thank you. And Ms. Rahman from Australia, you had some comment. Do you still have some questions and all, or are you okay with the response?
Thanks, Mr. Ravi. Thanks for giving me the opportunity. Yeah, so yeah, it was very nice to hear from two different perspectives from two different continents and from two different presenters. But and thanks for their general overview as well as technical insight. But I just try to understand from their presentation and the conversation, what are the limitations that challenges the greater adoption of biopesticide both in Sri Lanka and Russia? And my understanding is, as Igor mentioned and Kumara mentioned in his presentation, the slower action, the efficacy, the farmers understanding, the formulation stability, shelf life, and all these things. So that's pretty clear. Now we know and we understand what are the problems, but the question is that I don't really get the clear answer, which is what we could do in terms of solutions. So this is what I want to hear from them, from their experience, what they think, what could be the best way to address these things from solution perspective, not from problem perspective. Thanks.
Thank you,
So
Ms. I think that's a very, very important point you make. I now pass on to Mr. Igor if he wants to respond on that.
Yeah, many thanks, Mr. Chair, for giving me the floor. So if we speak from other perspective here, from how to solve the problem, it's also what I started, that some research institutes, for instance, in Sri Lanka or in Russia, as we do, it's a good thing to produce and to strictly follow communication strategy. It's the thing that really works. It's also what doing different RPPOs or even at the IPPC level that they are doing. And we are in the EPPO region. Yeah, we also have a communication platform where we raise the awareness and where we show how we can improve the things. Not only say, okay, this bug or this of this bacteria are very harmful. No, we also need to, and also we show how can particular farmer deal with different approaches, and the application of biopesticides or biologicals. It could be also the approach, and we have produced in within our Federal Service for Veterinary and Phytosanitary Supervision, so which is also under the jurisdiction of our Ministry of Agriculture. We produce a specific platform which is called Agro Expert. And in this Agro Expert platform, we have, so it's a website, it's a web portal where everybody can search for specific topic, and they are structuralized. They're very clear, and everybody can just see on or just type in the search in the search block. So just use of biopesticides, and someone gets all the related articles, all the related materials. Also, what we are doing, for instance, in our very small region, so as we are located near the Moscow, we raising the awareness by some seminars. We also, what we're also doing now, as we starting some trials of biologicals applications. So now these are fungus which are helping farmers to in their combat against some rot diseases, especially rots at the tree plants. We have a specific trial where everybody can see this is a these trees are treated with help of our fungus, with our biological. It's also a joint research project with a specific institute, which is called, it's located in Krasnodar in southern part of Russia. And this institute is working very actively and in great collaboration with us, as we are, because we're institute under their authority and their institute under their Ministry of Education. And we are the Ministry of Agriculture. It's a good combination. It's a sort of synergy in order to combine academic knowledge and practical knowledge, and especially some regulatory knowledge and experience. And we are also showing this trial plots, and we uploaded the results also in publicly accessible platforms like social media, like video hostings. And that's why we are raising steadily. Yes, it's a very complicated and a long process, but some farmers are becoming persuaded and astonished, I can say, by some results of application of the biologicals, and they see that this substance is really worked if the farmers is strictly follow the guidelines. It's not just the thing he can apply in every season or just chaotic. No, there is a guideline how it should be applied. It's also similar to chemical, but we need to have some patience for that. And we also, like as a stakeholder from research and also from academic research, we need to, and not only need, we also show how can these substances work in particular field, and how it can develop and improve the quality of production at the real site, not in the laboratory, not the in vitro, in specific in open space, so in situ. So it's a very good approach to show field trials. So what that is what we are doing now.
Thank you. Thank you so much, Mr. Igor, for such a detailed and such an insightful response for the interagency collaboration you have in Russia. That's really very good to know. Now, for the same question, which Ms. Rahman has asked to both Igor and Professor Kumara, I'm shifting to Professor Kumara now. Would you like to respond to his to Ms. Rahman's question on the solutions for the farmers, how you look at the solution side as Mr. Igor has responded? Mr. Kumara?
Actually, thank you for directing that question for me. I have to tell in farmers' acceptance, actually, in our extension system is not much efficient in Sri Lanka. As well as the most of the farmers are depend on the pesticide seller's shop. Once we understand, most of the rural farmers are going and asking from the pesticide seller which one is the solution, which pesticide I have to spray my pet. Likewise, people are getting the information, and the farmers also normally, but he is get more profit that product is promoting. Likewise, that system is operating in the farming community in Sri Lanka most of. But even though the extension is uh, it's a functioning with the government spending a lot of money, even though that practical approach is there. So that's why, and also in our pesticide market, most of the companies depend import and repacking and selling. They are not willing to go and invest to produce or production firms. That perceptions, I think that systems we need to change somehow. Otherwise, farmer awareness, we can do that. Some amount we can convert to the biopesticide. Even now, you know that previous our government policy to convert 100% organic in very short period of time. At that time, lot of farmers, majority of farmers are suffered with uh, introduce the biopesticide or the biofertilizers. Then their assurity, uh, they are believing somewhat is reduced, because if we are going to introduce any products, we have to do a thorough research. Especially for the biopesticide, we have to do very thorough research, multi-locational trials. Likewise, we have to ensure whether it is effective or not within the different climatic changes or climatic zones, how it is effective. Like those kind of things we need to be adopted. Then we can increase the demand of the biopesticide in Sri Lanka. I think some other countries also may be like this. We are company are not going to invest for the production, and also companies are not going to do the research. There should be a private public collaboration with the universities or with the research institute, have to do some proper research. And also, once we get the research grant, within 3 years or 4 years or 2 years, we are trying to come with some products, because that is the requirement for the grant. Afterward, after grant finish, sometimes we are not following and we are not doing any other follow-up research, and continuous development is not happening. That is also one reason why the biopesticide, not only biopesticide, all the research outcomes are not promoting. Most of the research outcomes are only for the publications, no much potential to go with the real lab to the field level. Now, the recently introduced some mechanisms to innovation commercialization. If it is success, I think in future we can see some more promising results.
Thank you so much, Professor Kumara. And there was a question from Milan C also for you. Milan, are you there? No. I think the question was, Professor Kumara, are there any advancement in biopesticide R&D in Sri Lanka? And the former government moved to organic agriculture, banning chemicals for nearly 1 year.
Actually, yeah, in the Research and Development Institute, with that policy, most of the research and development institute and agencies are moved towards to do the biopesticide and some organic products. That is happening, but still it is coming some production because of that. Earlier there was no any allocation or any grants. If we submit the proposals, it is very hard to get that grants. But now the trend is somewhat is different, and now the Research and Development Institute and the granting bodies are uh, flexible, and they are concerning the giving funds and the priority for that biopesticide and organic and ecological based agriculture and the farming systems. Right?
Yeah, I have a question for you also,
Yes.
Professor Kumara.
Yes.
Are there any private sector in Sri Lanka which is trying to, any SME even, which is trying to manufacture biopesticide in collaboration with public sector labs and all?
In according to my knowledge, I think no. But some companies are trying to collaborate with that. But still, I don't know whether there is or not. I also went and discussed several companies, but they not given much attention to that. But continuously, some maybe they are that CIC holdings like companies may be coming out and uh, showing their willingness to collaborate, but I don't think still that not came out to the society, as well as no products available according to my knowledge.
Because private sector participation is crucial. In fact,
Yes.
even if you have to scale up later on, public
Yes.
sector is what? They will do research, they will give approval and all. Finally, scaling up and all, actual work will be done in the outcome level by the private sector. So I think you really need to look at that, and we can discuss with you separately at some time. We don't have much time now on like how Bangladesh has started. Bangladesh Agriculture Research Institute, Bari, has started collaboration with the private sector under one of our projects, and how they are moving ahead. I can give you a model on that, how probably you can think of in Sri Lanka. And we have a lot of private sector people joining today, and the most prominent one I see here is Dr. Ghosh here again. He has been doing a great job. I think you should be in touch with all. And if you need any support from us or any member of the this EPCOP group, please write to Darshika or me. We will be happy to respond and support. Yeah.
Okay, thank you.
And
Definitely.
now you know Mr. Igor, so I think you have another place to look at for collaboration and all, how you can really work with Russia. But for Igor, I have a question also, Igor, before we close, is in one of your PowerPoint, you mentioned very interesting terminology, biologization of agriculture. Biologization of agriculture.
Yeah.
What does it mean? Does it mean shifting towards agroecology or shifting towards conservation agriculture?
So that means wider and more comprehensive use of all types of biologicals. So biological, biofertilizers, biological means of crop protections, biological stimulants. And here, as institute which is dealing mainly with soil plant, or not soil, but with plant health, we are focused on the means of biological crop protection. And so yes, I think it will be a shift, because it's a global trend to reduce chemical application in order to preserve our nature, in order to preserve our soils, ecology, environment. That's why there will be a global shift. But from my perspective, what I see, it will be a good combination. We cannot simply forbid any type of chemicals, but in the same time, we cannot simply forget and do not need to forget about biological use. I think that the key will be in a good combination and the good synergy of both of applications. We can reduce chemistry, but we cannot simply forget about it. But biologicals should be for sure improved more and more. And the farmers are seeing efficiency of this, and they will apply more biologicals, I think.
Thank you, Mr. Igor. If you all agree, we can extend by 5 minutes more this webinar, because there are some interesting questions which are there from Mr. Lakshmi, from Dr. Nayak, and Mr. Vishy. Mr. Lakshmi, over to you.
Thank you, Dr. Ketrapal. Actually, I was trying to add on to what has been explained to the Australian gentleman who has asked Dr. Rahman on how do you get the acceptance for biologicals at the field level. Now, this is the question which is always a big challenge as we are going for the living organisms. The moment we need to look at the biological industry to grow to a 50% of the chemical industry by, say, 2050 or so, or 2032, we are targeting at something like about 28 billion. How do we go? We need to have more shelf life. We need to have a product which can work with a formulation in a better way than just it requires the microenvironment for the living things. In that case, as rightly said by Kumara, is working on the insect pheromones, which are very, very stable. And again, reasonably stable is the BTs or the neem. Yes, for some kind of a photo degradation in neem, rest of it may be with the formulation we can always overcome. But it is much better than giving the microbes directly. Now here, our company, AG Biosystems, we are working on bioherbicides. Nobody talked about this part. We are working with the bioherbicides, especially for the invasive weeds, like water hyacinth, Eichhornia crucipes, and Lantana camara, and Parthenium histosporum. Now, these are occupying, say, something like about $1.42 trillion as an environmental impactation. So there are good biological answers for this. We have a mycoherbicide developed on the basis of the crude metabolites, or a biochemical, which would be a very good answer, because this becomes like a very easy product, like any other elder cousin, like the chemical pesticide, where you can calibrate it very easily on a dosage, and it can be sold through a dealer, which is the kind of a markets either in India or Sri Lanka for small holding we can always do. Now, these are the things which we need to look at. And again, on the pheromones, we have a patent which is going to be a game changer, because we are not trying to apply the insect pheromone for mating disruption. Rather, we will be doing moving source of the pheromone, which can be confusing the adult males. So that can be worked with a better formulations. We can do wonders about it. I think these are all have to be, the innovation and research has to come hand in hand to take it and take the advantage of the possible expansion of the biomarkets which are going to come in the future, let's say 2032 or 2050. This is where we are looking at from industry point of view. For our bioherbicides, we have about 24 patents in 15 countries. Now, this is the area, like, I mean, let us not just look at only agriculture part of it, also look at allied areas. Otherwise, the invasives will be taking over us. Thank you very much for this opportunity.
Thank you so much. It's very insightful what you are saying, because we have to look at the environment side also, land agriculture, and look at the bioherbicides and things like that. I think that is a very valid point, and they'll be based on same principles of use of bioproducts, basically. Thank you so much. That was very enlightening, Mr. Lakshmi. Dr. Nair, can you have
Yes,
your
sir.
quick questions? I'll be
Good afternoon, Professor Kshetrapal. Thank you very much.
Yeah.
Am I audible?
Yeah, please.
My first question to Professor Kumar. You made a very good presentation and also highlighted the kind of R&D investment and not much progress as far as very few biologicals, biopesticides have been also released there. Most of the times it is probably taken from the other countries. But the point that I wanted to know is, see, in natural farming or organic farming, in which the country like Sri Lanka has gone in a big way, how did you prepare yourself to go for these natural and organic farming without much biological basis? That's what I observed in your presentation. And that to substitute, see, for pests and diseases, if it is not a chemical, then we need to have an alternatives in terms of biologicals. And was it the decision made so quickly without much preparation, or I just wanted to know your opinion? This is my first question to Professor Kumar.
Yes, actually, we are practicing the organic farming, and also there are farmers having their own recipe to produce some organic pest control as well as the fertilizer techniques. Those are not come as a product and also not come as a market, but they know the knowledge and they are preparing their own and they are using. That is also there. But the registered and the come to the market, it is very limited. And also some products import from the countries like India and people are using. And also so many farmers are using natural things.
Yeah.
As a naturally available things for the organic farming. Suppose the animal manures and vermicompost, vermiwash, and as well as cow urine, like those kind of things also people are using as a pest control products, their own, and also neem and some other herbal plant extracts. They are using the water extract and they are applying and they are controlling the pest. Likewise, so many tactics the farmers are using, and they are doing their organic farming.
So
Right. Yeah.
during the whole process of this organic or natural farming that you have gone through, are you satisfied with the way the pests and diseases are managed in that approach? At
Actually,
least you
that
must be
organic
having.
certification companies and agents are much more concerned chemical fertilizer, whether they are applied or not. But the pest control is not much concerned. Even some smallholder farmers are using the hand picking and hand collection and destructions like those kind of things.
But ultimately, at the end of the day, you did not have a good result, right? That's what I wanted to know from you.
Yes.
Yeah. Isn't it?
No much. Yeah. I agree with you.
Yeah. Okay. Then I have another quick question to Professor Igor from Russia. What is the extent of coverage of biopesticides or biogenization, whatever you have been coining a new term, especially in terms of pesticide, chemical pesticide versus biological pesticides used in Russia? Realizing that these biologicals like trichoderma that you mentioned, they all work under tropical conditions, tropical ecology, rather than the temperate conditions of Russia. So what is the extent of coverage of biologicals in pest and disease management in Russia right now? And what is the planning for next 5 or 10 years?
Yeah, Mr. Igor, I would request you to be brief in
Yeah,
responding because we have
yeah,
almost
okay.
the time.
I will be
An
I will
important
be
question. Yeah.
as brief as possible. So, as for conditions, our main production parts of crops are located in very warm and humid climate. So, in southern parts of Russia. Now, with the climate changing and when the climate shifts, the conditions are becoming more and more similar to tropical ones. That's why the evaluation says us that the biologicals, even originated from the tropicals, are well adopted here, well established here, and worked well. But this work will continue in the future and is still ongoing. And as for further projects, they will be developed, and I am 100% confident. Also, we have some non-governmental union of it's called of Union of Biological Producers, and they're working actively on registering new biologicals and developing new biologicals and encouraging new stakeholders to in this topic. I think it would be also a good point to involve them in joint researches, but it will be also a good public-private cooperation approach. So there are lots of perspective from my point of view.
Thank you. I think we have had a very active discussion and we can go on and on, but it's a limitation of time. But before we close, I will request Dr. Stella Simiyu Wafuko, who is a regulatory affairs deputy in Crop Life Africa, Middle East. She made an excellent presentation in one of the COPs few months back, and she is now looking for co-designing the Biocopa Index. And my colleague Tarshika has given a website also where you can link and you can give your input on what kind of indicators you need for what kind of activities and all, which I think is a very important way forward in the field of biopesticide. Ms. Kala, are you there? If you are, I will give you a floor for 1 to 2 minutes to highlight that so that we get more response.
Thank you very much, Dr. Ravi. As you have mentioned, yes, we are indeed looking for co-designing with the different stakeholders. So the Biocopa Index looks to provide a measurement, a tracking of growth of how biopesticides are being undertaken in the country and which areas the country needs to improve on. So I'm inviting every stakeholder to co-create, just look at the different areas, the R&D, the industry competitiveness, the registration process, which is a policy process. So in each of the categories, we have indicated some indicators for measurement, and I'm sure from these stakeholders, there will be more suggestions of what we need to include and what we need to leave out in summary. And thank you, Dr. Ravi.
Thank you. Thank you, Ms. Kala. That's a very important mission you have taken. And I believe many of us will come forward for co-designing, but you remain the key flag bearer. So thanks a lot. And
Thank you.
with this, sorry. With this, I would like to thank each and every one of you for your very patient listening, for your active participation, and especially I would like to thank Mr. Igor and Professor Kumara for their presentations, which opened a lot of possibilities of collaboration, networking, challenges, opportunities. I think this platform is really going to help a lot. Please feel free to contact Ms. Garshika or me for any information you need. And especially, I was happy to see one in the chat, one message from Tanzania, who wants to collaborate with the biopesticide workers in Asia. And I may like to inform him that we had worked with the SADC countries, that is the South Africa Development Community, where Tanzania has been an active player. We'll share with you all the details, and we are open for any collaboration. Let us have a one-on-one discussion, and we'll see what we can do for each other. So with these few words, I would like to stop here and pass on to my colleague Darshika to close the session.
Thank you, Dr. Ravi. Yes, as we are conducting the today's session, and I would like to express my gratitude to both speakers, especially Dr. Kumara and Dr. Igor. And then I would like to extend my sincere thanks to all the experts contributed in the discussion today. And if you have any comments or suggestions, or if you need any advices or anything related to biopesticide, we would like to facilitate it, as Dr. Ravi mentioned. And feel free to reach out to at us in emails. We would be happy to help you in any way. So thank you all, and we look forward to having you in the next session also. So thank you very much. Thank you, everyone.
Thank you. Bye-bye. We can